Hi guys, today I'll be talking about exploring Jetpack Compose and crafting seamless experiences along with dynamic interactions. I'm Nirbhay. I'm currently an Android engineering lead at Movie. I primarily work on core engineering efforts at my company, like building SDKs, configuring libraries like tracking libraries, or any other core configuration libraries. For example, let's say if there are ads being used in the company, then I build like an ads configuration project, stuff like that. I also help in architecting new products and flows. For example, if I say we are coming up with a new product based on existing products or just like a child product, something like that, I make sure that I'm in that team, uh, helping out and getting it on track. In addition to this, I also manage development efforts for our messaging team. We have apps under our messaging suite like the Messenger Launcher, a Messenger Lite version as well. So yeah. In addition to that, I love hiking, as you can already see with the photo on the right side, and that's a photo from Zion National Park. All right, all right. So let's get into the agenda for this session. Um, we'll be going through five main topics. If time permits, we'll get to the fifth one, or it depends. Um, the first one is going to be we're going to just first have like an introduction to Jetpack Compose and understand that what it is and how is it like slightly however how is it different from the traditional approach of building apps with Android. Next we'll move to state management. Um, and I'm just going to highlight the points right now, but get more deeper into it when we get to the slides for those topics. We'll also be doing animations and how we can build simple animations in Compose. We'll be going through navigation uh, in Compose between screens, standalones, and we'll also be having something called as a pager and see how we can navigate from standalones to the pager and to and fro. Finally, we'll also be showcasing an arcade game that I've built with Jetpack Compose and provide you with all the resources that are needed going forward for you. All right. So here's the big question, right? What is Jetpack Compose? Jetpack Compose is a modern Android UI toolkit that simplifies, the process of building native Android user interfaces. Um, so these are, the key points that one might come across once you start building with Compose. These are some points which are like the most highlighted ones, which stand as a differentiator when building apps using modern Android programming. One, Compose is uses declarative UI. What declarative UI basically means is it allows developers to describe the UI in a declarative manner, specifying how the UI should look based on the current state of the app. And when I say state, it basically means what you are seeing visually live at that particular moment. UI as code. So unlike older Android UI frameworks, Compose allows you to define the UI using code, making it more flexible and maintainable. So when I get into the example, you will understand like what I mean by that. Um, it's Kotlin powered, so Compose is fully integrated with Kotlin, leveraging its language features and providing a seamless development experience. And finally, it's designed for sure for modern Android. It's designed to work well with Android's latest features and supports both new and older Android versions. Okay, so how does it really work? We're never going to really understand it if we don't, like start with it. So let's actually get into it, dive into it, and let's see it in action. So I'm going to pull over Android Studio here. Okay, all right. So I'm going to be like I've opened Android Studio here, and I have a very simple, basic, empty activity ready. Um, So, we are all aware that, we usually we use app combat activity, we extend that. But, if your app only has composables and you're going to be just using composable throughout, then you can, instead of using app combat, you can use component activity. But of course, if you're migrating your app from, let's say, older code to compose, you're gonna have a mix of stuff till you get there. So till then you'll have to use app combat, and then once you're done, then you can change it to just using component activity, which is the preferred way of doing things now with the modern programming approach. Okay, so here I'm going to be actually creating a very simple custom button, and see what are the benefits of doing that, and how we can use the same approach to create more components, more composables, and basically build a more scalable application which can have a lot of reusable components, which would be used across screens, across other composables as well. So yeah, so to create a simple composable, we need to first annotate the function with @composable. I'm going to call it my button, which really basically going to have three parameters. One is going to be the text on the button. I'm even going to have some default text here. Next is going to be a text color. So I'm going to give it like a default color, maybe color dot red. And then finally, what happens when we try to click on the button. So it's basically going to accept a function as a parameter, and then that's what would get executed when the button gets clicked. So here we're going to be using the button function provided by Compose. Again, an on click is something that we have to pass if we want to use buttons, and so so here we're going to just call whatever is passed to us, thus making the clickable functionality reusable on the button. Now we will also need a text composable here for the text on the button. In here I'm going to be specifying maybe like whatever the text is passed, use that, and whatever the color was provided, I'm going to use that. Alright, so our button composable, the custom one, is ready. So before I dive into how we should be using this, or how we can use this throughout the app, I'm going to show you something called as preview. So this preview is basically an annotation that's provided by Android to see hot reloads of your of the changes that you're making. So as you can see, it previews this particular composable, and now if I change something here, then you can see the loading data here. So it's trying to reload it again, and you'll be able to see the change again. So this is very helpful. As you can see, my button X, it's very helpful from the point of view of if you're building so many components and throughout screens, stuff like that. So you can quickly see that what you're building is right or no, and you don't have to again and again reload the entire application and see that oh, is it working or not. So yeah, pretty has significant advantage when you're developing. So basically you become a more preview driven developer there. Okay, now how do we use it, right? So here, and actually see it on the emulator on the right side. Let's switch off this preview, and yeah, so I'm going to be creating maybe 3 buttons. Oh, and before I do that, actually we'll be using something called as column. Column is somewhere you can list components one below the other. Okay, so I'm using my button here. For the first one, I'm not going to be specifying any color or anything. I'm just going to say maybe the text only. So I'll say something like A1. Then I'm going to add another button. This time maybe I'll do a custom color. So I'll do something like A2 text color is color dot green, and then I'll do another one. But this time maybe I'll try to use the on-click functionality that is provided, so that we can see it in action. and actually something happening. So, right, and finally click. So here I'll be seeing like D A3 here, and let's click. All right, and there we go. Right, so I'm going to run this now. Alright, so there we go. We have our 3 buttons. So that basically proves that, like once you declare, you can use it as many times as you want and wherever you want. And the more the properties you have here, the better it is. And if you have set up default properties, then you can, have very consistent looking UI throughout your application. You might want to even check out themes with Compose, like material themes. It's very helpful while building UIs. Okay, so let's see if that A3 is working or not. Okay, so I'm going to go ahead and try to click on A3, and there you go. I was clicked, so that works. All right, let's move back to the slides now. This is what we really observe, right? These are the core benefits of using Composables. One is rapid development. It's fast. Once you build, you can quickly start reusing your components. It's modular. So especially when you think from the point of it from just maintenance of code, it's so much easier, and you can have your code like especially like your components in one place and then your screens in one place, and your screen itself is a composable of so everything is a composable, everything is a component, and yeah, you can just reuse it across screens, across components, and just make sure that you have you build it in such a way that you have default properties as well as properties that you can define while coding. In addition to that, when it comes to rapid development, as we saw the hot reload feature for real-time UI updates, it significantly speeds up our development process, because we can quickly see on the screen itself if the component is working like it should, and then if it does, then we can just start using it everywhere wherever we need to. Finally, it's very good with consistency across devices, because it ensures a consistent UI experience for different devices or screen sizes too. So yeah, all in all, really solid. So the next topic we're going to be talking about is state management. Let's try to understand first what is state really. So state represents the data or the information that defines the current state of your app's user interface. When I say that, what I really mean is whatever we see visually is the current state of the app. So whatever is present in front of you on the screen, that is basically the state of the app. So in Compose, the components themselves can be holding states, and there can be some components that that are dependent on states and some that are not. So based on that, whatever is needed, whatever changes, only those components really get rendered, and that's how the app remains stateful. So the next thing that we're going to be talking about here is understanding the challenges in traditional state management. So now we're going to go back, and first try to, compare to how it used to be in the old ways of doing things, and then come back to Compose with a real example, which we'll code live, and understand the benefits of, using Compose over traditional techniques of state management. So as you can see here, uh, in a traditional app, using XML-based layouts and imperative UI updates, managing the state of a simple counter can lead to complex code. Here's a simplified example in Java on the right to illustrate this. So as you can see in this code, we need to manually find and reference the UI elements from the XML layouts. So as you can see, like for the increment button and the decrement button, we have to actually go ahead and like even for the text view, we have to go ahead and get those from the XML layouts. And even if you use data binding and like Kotlin and all that, uh, still like you gotta reference it from its referenced via XML. Um, we use listeners to handle button clicks and manually update the count and UI elements. So as you can see, like there is a set on click listener on both the buttons, and which basically has the on click and getting overwritten, and then we are actually manually updating the counter and then manually setting up the text there as well for both the buttons. So as the app will grow, managing the state and UI updates for multiple components can become very, very complex. And this is one of the challenges in traditional state management, which is basically complexity. The second one is synchronization. So this challenge basically arises when ensuring that UI and data are in sync. So if we forget to update either the count variable or let's say the count text view text, the UI will display incorrect information. So if we don't have that set text, we might see incorrect information. And finally, the third challenge is reactivity. So reacting to changes in the count is not automatic really. So we have to explicitly update the UI elements when the count changes. This can lead to more boilerplate code, especially in larger and more complex apps where you have so many different components that you might be using in your app. So these challenges basically demonstrate why traditional state management in Android can be error prone, and it can result in very complex and hard to maintain code. With Jetpack Compose, these actually get addressed by providing a more declarative and a more reactive approach, as well as the UI updates would be automatic, and state management is actually much more straightforward, um, and it reduces the potential of having errors too. So, yeah. Now we are actually going to go ahead and demonstrate states with an example. I'm going to be pulling up Android Studio now. So, okay, so to understand states better, let's now go ahead and build a simple counter app with Compose, and I have like the empty file ready here, and with an empty composable right here, and I'm just going to start filling it with the important key pieces, and then maybe replace it with a little bit more better UI. I have the code for that one ready too, but first I want to just show you uh, the key elements of how states would work in this function. So I'm going to first define a state variable. We call it counter, and this is how we do it. And let's say the initial value is 0. And what this basically does is that it would remember the it basically keeps track of the state variable, and whenever it would change. So let's say if we try to increment counter or decrement counter, whatever whichever component a composable is basically using counter would get rendered again. So let's show that to you with an example. Okay, so let's say we have a text variable here, like a text composable being used here with say counter, counter, and let's have a button uh, with say should update the counter, and so the button you can have something like increment counter, and I'm going to put again both of these in column. So as you can see here, what we're basically doing is this text composable is using this counter variable. So whenever this counter is changed, this should get updated. So this should get rendered again. And the button will be taking care of that for us. So button will basically be updating the counter whenever we click on it, and whenever it changes, thus making this entire process reactive. So I'm going to go ahead and run this code. Show you like how it works. Alright, so as you can see, the counter here is 0, and if I press increment counter, things should change. So as you can see, it goes to 1, 2, 3, 4, 5, 6, 7, and yeah, basically it works. Okay, now now I'm actually gonna not use this code. I have another file right here called counter. In here, you can see that. See, let me do one thing. Let me take this and replace it here and change that to counter. Okay, so here basically we are going to be doing the exact same thing that we did there, but I just have a little bit more better UI, and instead of just having increment, I even have like a decrement button. So I have one for going down and one for going up, and it's just to for better demonstration purposes, and it's like better styling. Other than that, there are not many major differences. Just to show that how much can we really do when it comes to states and how they can be changed from multiple places. How can we trigger events from multiple places and render elements reactively. So I'm gonna rerun. Alright, so as you can see here, we have a decrement button and we have an increment button. As you can see the epilator. So if I click on the increment button, it will go up, and the decrement button goes down. Obviously, it's because on the increment button we have count plus plus written, and on the decrement button we have count minus minus. And here we render the count, and this is where we declare our state variable. And that is it. Okay, so coming back to the slides, right? What do we really learn here, and what are the key benefits of doing this over the traditional approach? First of all, of course, reduced boilerplate. So Compose is definitely eliminating so much of the boilerplate code that was required for state management in older Android frameworks. The UI updates are super simplified. UI components now automatically update when the state changes, reducing manual synchronization efforts like we were doing for each of those click listeners that we had added in the Java code that I showed you earlier. And of course, like code readability wise, also it improves a lot. So declarative state management makes the code more concise and it's easier to understand. Um, so it's as simple, right? So you're incrementing. So all the buttons that are really doing, like the on click is doing, it's changing the state, but you don't have to go ahead and update the text again and again, because the text uh, just the text would automatically get rendered, because that's what it does. The job it has is to show the counter. So yeah, this is all that state management is about, and of course there are like a lot more other ways of declaring state variables and using them, and I've provided resources for that at the bottom of the slide. So yeah, feel free to check those out too, and yeah. Okay, so the next topic that we're going to be talking about is how do we build animations with Compose, and dynamic as well, of course. So, but we'll be doing like simple animations, maybe like something like scale in, scaling out, or like fading in, fading out. There can be others too, like sliding in, sliding out, stuff like that. So, but first, before we even dive into that, let's try to understand the challenges that are associated when creating animations traditionally. So, um, like if you see the code on the right, um, we have a simple view, fade in out view, that we want to fade in and fade out. We load two animation resources, one for fading it and another for fading out. which are basically the fade out animation, fade in animation variables, final variables. And we handle the click event on the view to trigger the animations based on the current state. So if it's fade in, then it starts the other animation, like the fade out animation, and if it's already in fade out state, then it starts the fade in animation. So there are three like real challenges with this. So first one I would talk about is complexity. So traditional animations require manually loading and managing animation resources. You need to create separate XML files. So for example, you have to have a fade in XML file and then a fade out XML file to define the animations and load them in the code. The second issue here is a challenge is ensuring that animations are synchronized with user interactions, such as clicks. So that could be challenging. So in this example, you must track the state, right? So if it's in fade in state, then it has to play the fade out, and if it's in fade out, it should play fade in. Finally, boilerplate code. Handling animations in this manner often involves writing code to control the timing, delays, and interpolators. So how we can overcome these with the more modern programming techniques is what we'll come up with in the next slide. Okay, so I have Android Studio open up here now, and again, like I have like an empty file and a simple composable ready for us to go. We are going to be building a scale animation. Basically, what happens here is we'll have an item fully scaled, and then when we click on a button, it would like go down to 0, and it would basically look like we are zooming out of the screen, something like that. So to build that, we'll be using something called as animated visibility. Okay, so animated visibility is a composable that helps us simplify the process of creating animations by providing a declarative way to animate components. So it reduces the complexity and boilerplate code required to do animations. So okay, so the first thing that it takes is whether it's visible or not, like whether we want the variable, like the animation itself, to be visible or not. So for that we would need a state variable. So I'm going to be declaring that here. Let's call it visible. I'm going to say for now. Okay, once it's done, we'll be using this variable here. Sorry, that was the wrong variable that I was using there. Next, what animated visibility allows us to pass here is an enter and exit type of animation. So in our case, we would basically have something like when it's entering, it should be like scaling in, and when it's exiting, it should be like scaling out. So because we are doing a scale animation, it can even be like combination of things. So another example would be like for while entering, it would be something like fading in, and when exiting, it would be like fading out. So I'm going to go ahead and at the end. Okay, so scale. So this basically accepts two arguments, as you can see. One of them is the animation spec, and the other is initial scale. It also accepts something called transform origin. So animation spec here, it basically defines how an animation should behave, including its timing and interpolation. And coming to the initial scale, it would basically be like, should it start from the highest grade? So in our case, it would be something like we would say start from 1. So Here I'll be using something called as tween. So, and providing a duration to it. So it's basically like, in constant time. So what I mean by that is it specifies that the animation should transition between the current value and the target value over a duration of, we provide 600 milliseconds here. So it will basically use like linear interpolation, so like constant speed. And yeah, it expresses a float value, so that's why it's giving me that error. Okay. And we also need like an exit. So we'll be saying like scale out. Scale out, we'll be saying target scale. So because we're scaling out now, so we need to know what the target is. And now we will say something like 0 and animation spec again so between about 600. Okay, so whatever contents are there inside this composable is what the animation will be applied on. So if I say like text, okay, maybe even give it like a font size of 22. Right. Now we would obviously need something to control this animation, so I'm going to add like a button as well. And add the button. Right here. Oh, sorry. Here we want to make the visible pose. Alright, so we do have like our animation ready here, and let's see how it would look. Alright, so we have a go scale button and we have hey there, and it's scaled to, like we see, it's scaled to the entire screen and it's visible right from the beginning. So if I press this, it should scale out, and there you go. So as you can see, does work. Okay, so I'm next. What I'm going to be doing is I'm actually going to be bringing over some other code that I have written here in this animation.kd file. Here I have a function called setContents, which I'm actually going to rename to scale x. And okay, so what this basically does is I'm going to just go ahead and first run it for you. I'm going to stop using this function. Alright, so I have a button here, so it's called trash it, and we have this text Apple. It basically does what I really showed you right here before this, but I just wanted to demonstrate it a little bit more, like in a way where we can see that how we can make this animation more reusable as well, and how it would make more sense in a real environment. So so here basically we have this button like we had one there for Go Scale. And this button is visible only when the text would actually be visible. So if Apple scales out, trash it also goes away, which makes more sense. And finally, I we're using the same function like the scale animation. It's the same thing that we did earlier, but we are accepting more parameters in the function itself so that we can reuse this function. So here I've specified that, it should start at 1, the end scale should be like 0.2, and I should do it in like about, 3000 milliseconds. So I'm going to now click on trash it. So as you can see, it goes all the way and it's done. So yeah, this is what basically scale animations are. Similarly, we even have the fade animation built in here. So it's basically the same. Instead of scaling, we're going to be using the fade animation, and in the fade animation, instead of using scale in and scale out and for enter and exit, you're going to be using fade in and fade out. And instead of using the initial scale and the target scale, we'll be using initial alpha and target alpha, which is basically alpha is basically transparency, which also is in float. So I'm going to just show you quickly, how it would look like. So I'll just create button here, and if I click on it, it shows up Apple. So as you can see, but this time we are just doing a little bit differently. We first show the button, then we get rid of the button, but we actually show the animation. So, and this too is reusable, like we can see here. All right. Okay, so coming back to the slides again, when understanding the benefits of this over the traditional approach, we see that Compose definitely makes it easier to create complex animations with animated visibility and a very minimal code. So yeah, it definitely is pretty good when it comes to simplicity. Consistency is another thing. Like animations are going to be consistent for you when across different devices and screen sizes. And finally, when it comes to reactivity, animations are automatically going to respond to changes in state when using animated visibility, as you can see, like with the state variable that we used. So yeah, that's about it. Okay, so next topic that we're going to be talking about here is seamless navigation between Pager and standalone composables. Uh, so let's get first. Let's try to understand what really are standalone composables, or screens, if we have to say. So I'm going to explain it. I feel it's going to be better to understand it with the help of an example. So as you can see on the left, there is this image. So I built an app called Quest, which is basically it's like a collection of stamps, virtual passport, national park passport stamps uh, per national park. So but like the screen that you see, like the home screen, that's one of the screens, and we would call that a standalone composable. So it's like basically just has a way to reach different like other screens, and that's all that really is. So that's one standalone composable. The other one could be like search. The third one is about, and the fourth one, interestingly, is the one which shows up when you click on my passport stamps on the home screen, which would open up a pager actually, which we'll get into soon. That's why I've kept it blank for now. And but yeah, so there are basically four standalone composables in this app, and so on your right. I've just declared three for now because those are the simple ones, and the fourth one is passport, which we'll talk at the end when we understand pager better. So what we're doing here is understanding how to navigate just between standalones for now. Before we dive into how to do it between standalones and pager and to and fro. So for that, the first thing that we need is a nav host, which is Composable, which is provided uh, by Android to navigate between different routes. So I have like a app route class which basically maintains the different routes that we can have in the app. So for us, it would basically be home, about, search, and then again, of course, passport is the fourth one. Um, So yeah, I've just declared that under an app host, and I have a start destination, which is basically that the app should start from the home screen when we first time load the app. And so if someone wants to go to about, so let's say if someone clicks on about here, we would be using the nav controller, which has been defined in the first line in the app function, to navigate to that route. So it basically be saying nav controller dot navigate uh, to app routes dot about dot name. So that would take it to the about section. So that's simple. Um, let's go ahead. Okay, now let's try to understand what is really a pager. So pager is something which has like swipeable composables in it. So like you can swipe to your left, as you can see in the GIF here. So this is our passport. Like as I said earlier, right? Like the entire passport screen is one composable, but inside that it has a nested horizontal and vertical pager. So what I mean by that is, as you will swipe right, you will be getting more and more passport pages. But on any particular passport page, when you swipe towards the bottom, you're going to see photos like you're seeing in the GIF, and that's the vertical pager on every horizontal pages index. So that's basically what a pager is. So we can so that we can keep swiping through content easily. So, and as you can see, it can be nested too. So it's like pager within pager. So we have like a vertical pager on every index of the horizontal pager here. Um, that's what basically pagers are. Pagers themselves also have like a pager state. Um, so I'm gonna get into that here. So how do we first, let's first understand how do we, build a pager really. So horizontal pager, all it needs like horizontal pager state, and to that pager state you can provide how many pages you want horizontally. So let's say I want 10 pages horizontally, and where do I want the like when I open that particular composable with the horizontal page of where do I want it to start, like which index. So let's say if I want to start from the 5th index, you should be able to do that. So you can provide the initial page on that, and then basically use the horizontal pager composable that's provided by Android, pass in the state, and and then you basically have the page and that you get back in the Lambda, and you can use that to render content for that page, whatever you need. Same is the case for the vertical pager as well. Uh, all right. I hope that has not been too hard to understand. Um, okay, so coming back to that final fourth route that I was talking about earlier, and how do we build the passport route, and how do we navigate from place like somewhere in the standalone to, let's say, so somewhere on a particular page. So for example, let's say you're on the search composable search screen, and you search for a particular photograph, and you want to go to the third the third index in the horizontal page, and the sixth photo in the vertical page under that horizontal pager index. So how do you do something like that, right? So this is where we can pass variables like arguments in the route itself. So we would basically be using the passport route, but in addition to that, we would be passing the horizontal page index and the vertical page index as well, and we get that in this composable itself using something called as backstack entry. So backstack entry has the arguments in it, and then you can retrieve it. So the template here that is basically being used is horizontal page index slash vertical page index is appended to the passport route, and we get both of those, and depending on that we render the passport composable, which you can see on the left. So uh, basically, all we really do is we pass the horizontal page index and vertical page index to it, and based on that, the actual uh, horizontal pages and vertical pages are created with that particular initial page, which we just talked about. So this is what I'm really talking about. This initial page right here, uh, for both of those, is what would be used when passing the horizontal page index and vertical page index. So we by default have them set at 0, 0, but whatever we pass, that's where it starts from. So that's basically it. And let's say, again, like if you were in the search screen and you wanted to directly navigate to it, so again, you would use nav controller dot navigate like we talked about earlier to go to any standalone composable. But the only change that we would be adding here is /t/6, which is basically third horizontal page index, and then the sixth photograph on the vertical page. So that's about uh, that's about it as far as navigation to and fro is concerned between pages and standalone composables. And of course, if you'd like to learn more about how this works and how this ParkQuest app is built, you can feel free to read through my article, and it contains all the code snippets and the GitHub repository as well for an even more better and in-depth understanding of this topic. All right. As I had mentioned earlier, I was going to demonstrate like a game that I built with Jetpack Compose. It's an arcade game. I call it Flappy Musketeer. It's actually Elon Musk based, theme based, but like a more modern twist of Flappy Bird. Um, of course, I have all the the technical code and the documentation, and it's open source. So feel free to check it out. It's actually pretty good to understand more about states and states in general. Even like the pager stuff. Like if you want to get a little bit more understanding of how pages work, like um, you can check it out, and navigation too. So yeah, uh, that's this would actually be pretty helpful, to at least as far as from the point of view of just understanding states is concerned. I think it would be a pretty good um, example to look at, and also understand that how powerful Compose can really be. That if you can build games with it, then just for doing like normal tasks, how good it really is. Or building like smaller apps which don't require that much resources. So yeah, feel free to check out the link. It's the Linktree link, and yeah, follow up with me on some feedback too if you have it. I also have some helpful resources for you here. If you want to understand states completely, like in depth, um, please go through the documentation like provided by Android. It's very useful, and you understand not just about what I have shown here in this session. I feel it's much more out of the session, like scope of the session, because there are a lot more ways in which you can build states, and you can interact, and also how view models can come into the picture, stuff like that. So do check it out. For animations too, the same applies. Like animated visibility is not the only way to do animations. There are like other things as well. So feel free to check that out. Also, there's something called modifiers that I really didn't discuss in this session, but you might want to learn about, like what modifiers really are and how you can have different modifiers, and how you can use chaining to build your modifiers for the composables that you build, or the components that are going to be using, the reusable components that you're building, and how useful it can really be. And finally, I've also added a link to my blog, which has a bunch of articles and that I've been writing on Compose and Kotlin, and can be very useful. So yeah, do check it out, and also feel free to leave a feedback. Or if there is any other topic you'd like me to write about, feel free to do that too. Finally, I would like to say thank you so much for watching, and being there here till the last slide. I really appreciate it, and I hope like I was it was helpful for you, and you've learned something today. Also, feel free to leave your feedback, and you can always contact me. And to learn more about me, here's my link tree too. It contains links to all my social profiles, and my email address. Um, Thank you so much.